Distance and displacement. Let's start with the definition of distance. So, what is distance? Distance is the total path traveled by an object, meaning if we have here a Gaussian plane, then we're going to trace now the distance traveled by the object. Let's say the object starts here. Let's say this is A, and then it moves back here. Let's say this is B, and then lastly, let's say it moves down here. Let's say this is C. We're going to assign some values here. Let's say this is 10 meters. Then suppose this is 30 meters, and then this is 20 meters. Now the question now, how much is the distance traveled by the object? So what we can do now is simply get the sum. So in finding the distance, or sometimes this is represented by d, this must be equal to the total path. D must be the sum of ln. So let's say this is from I to n. So all we have to do here is simply sum the length of path traveled by the object. So in this case, what we can do is get the sum from A, B, and C, and we get 10 plus 30 plus 20m, and thus we have 60 meters. So this will be the total distance traveled by the object. Displacement, and since this is a vector quantity, thus direction will matter. So by definition, displacement symbolized by this is the shortest path which can be located by making straight line from the origin to the head of the last vector. If we go back here, this one, so the displacement here, if I were to locate the displacement, then the displacement must be a straight line that connects the origin and the last vector. And this will be our displacement. Okay, example. Let us have, suppose, one dimension. So this is our origin 0. Now, these are all the given vectors. So let's say vector A is 10 meters east. Let vector B is 20 meters west, while vector C is 2 meters east. So let's start with A, vector A. So east, if we have here uh, the direction, this is north, south, west, east. So vector A, that's too much, that's 10. Let me just delete it. Okay. Okay, so let's say this is 5. Let's start with A. So A is moving 1 meters to east. So from here, it moves 1 here. This will be our A. Next is B. B is moving 5 meters west. So from here, you have to move 5 to the left. So 1, 2, 3, 4, 5. This is for B. Now for C, it moves 2 meters east. So east. So 2 meters. From here, we have to move 2 meters. 1, 2. And this will be our C. And this is where our last vector is located. Now, what we can do here is actually find the resultant, where the resultant is nothing but a line that connects the origin to the head of the last vector, and the head of the last vector is here. So we have to count. The answer here is 1, 2. The displacement, which is symbolizes by this one or bar, is 2 meters due west, or you would say negative 2 meters. Okay, that is displacement. Now, since this is just a one-dimensional representation of 1D, for 2D, let's have an example for 2 dimension. Okay, so let's say we're given the following vectors. Find the displacement. So how much is the displacement? So first we have to graphically illustrate or draw or trace the following vector. Say vector A is moving due east with a value of 3. So 1, 2, 3. This is our vector A. Next is we have vector B moving due north with 5 meters. So this is our B1, 2, 3, 4, and 5. So this is our vector B. Now on the other hand, vector C is moving due south with 8 meters. So from here, you have to count 1, 2, 3, 4, 5, 6, 7, 8. So this is our vector C. Now what we can do now here is in finding the displacement, we have to find the resultant vector. And the resultant vector is a line, the shortest line that connects the origin to the head of the last vector. And this will be our displacement. And it can be calculated, can be solved using the resultant vector. So in finding the displacement that is actually equivalent to r, which will be the sum of x squared, if you could still remember this formula, and then the y squared. I have a video of this one. Just look in the playlist and you could get result for the resultant vector, and that should be equivalent to our displacement. If we solve for this one, our d must be square root. So our x here will be 3m squared plus our y here will be negative 3m squared. So this is 3, this is also 3. So we end up with 9m plus 9m. We have, okay, this is squared, this is squared, so we have 18m squared, and therefore our displacement must be 4.2426 meters. And this is the value of our displacement. This is the magnitude of the displacement. Now to solve for the direction or the angle, we have to use this formula, if you can still remember. Tangent negative 1 of summation of y, the absolute value, and then summation of x, the absolute value. Okay, so the angle will be tangent negative 1 of 3 divided by 3. That should be actually 45 degrees. The angle here must be 45. That's all for distance and displacement.